Welcome everybody. It's Ramchandra from Civil Mech Maths Concepts. I have already released Fluid Mechanics 1 on the properties of the fluids, which is a very important topic. Today I am releasing this Fluid Mechanics 2 properties continued. In this I will be discussing surface tension, capillarity, force units and units of various pressures, types of pressures, and I will be discussing on the units of the fluid mechanics properties. And best of luck to everybody. Please listen to my lecture. Welcome everybody. It's Ramchandra again. Today I will be continuing the discussion on definitions and properties. It's lecture number 2 on fluid mechanics for the benefit of SSC JE civil and mechanical aspirants, GATE examination aspirants, and also CSIR and UPSC examination aspirants. I have given some detailed definitions and properties in the lecture number 1. Please refer to them. And as a continuation of it, I want to give today some preliminary definitions from physics to understand better the definitions and properties of fluids. Some 2 or 3 quantities from physics I will define. Then again we will move on to the fluid mechanics definition. The first is force. Force is a vector quantity and it is the product of mass and acceleration. It is as per Newton's second law. Newton's second law. Second law of motion. This can be graphically represented as some object is there with mass m. A force is applied in this direction, positive x direction. The object is moving with an acceleration a in the direction of the application of the force. Then it implies F is equal to, in the absence of any other forces, F is equal to ma. This is the definition for force given by Newton, and in honor of him, and the force is measured in newtons. N is newtons. Now, force is equal to mass into acceleration. Mass is in kg as per SI units. Acceleration in meters per second square. Kg into meters per second square is equal to Newton. This is the basic unit of derived unit of force. Mass is kg, acceleration is meter per second square. From this unit is called as Newton. Please remember, force is measured in newtons and which is equal to kg meter per second square, and force is a vector quantity. If an object is subjected to not to an external force but subjected to gravitational acceleration g, then the force of attraction by the gravitational force towards the center of the earth, it acts towards the center of the earth. In this case, Fg is equal to mg. Gravitational pull we can call, gravitational force we can call. This is nothing but weight. We will sometimes call it as a weight. It has the same units as acceleration a is replaced by acceleration due to gravity g. A is replaced by g, and it has the same units of kg meter per second square, and the units are Newton. where G is equal to 9.81 meters per second square on the surface of the earth. And in physics, there is another vector quantity which is defined as movement. That movement is nothing but it is a vector. Again, P is a vector, like F is a vector. Mass into velocity. M is mass. This is velocity. Velocity is a vector quantity. And this is measured in kg meter per second, which is nothing but force into time. Time is in seconds. That is equal to Newton second. Force into time. Next, we will define another physical quantity called as torque. Torque is also a vector quantity. I am giving these 2-3 examples in detail because these are all very useful in the following definitions of fluid mechanics, not only in the definitions of fluid mechanics, and also we will extensively apply these in the fluid mechanics analysis. Torque is, for example, a rigid body is there and a force is applied here. A force is applied here at a distance of r from the center of gravity of the rigid body. Then torque. Due to this force, there will be a torque developed. It tries to rotate the rigid body. If center of gravity is here, Cg, about Cg, when force is applied at a distance of r from Cg, a force of F is applied, then torque developed is equal to F cross R. Depending upon the direction of the force and the movement developed, or it is also called as movement of the force. Movement of the force. This movement is different from movement explained in P is equal to movement ma. This is different. This is different. Movement of force. It is movement of force. That movement is due to mass and velocity. This movement is due to force. This movement of force is equal to N is Newton and R is meter. The distance between the force, applied force and the center of gravity. The units of torque are Newton meter. Please try to understand the movement. Here in physics, while defining force and movement, that is different. Force is nothing but rate of change of momentum. This we can even call it as momentum. Rate of change of momentum. Whereas torque is moment of force. This moment of force is in Newton meters. Now, once we know these basic physical quantities, when this force is applied for a small time, then this is called as moment, and when it is calculated as mv, it is called as momentum. Either way, don't get confused between moment and momentum. This is for small time. Ft is momentum, whereas torque is moment of the force. It is not movement or momentum from velocity. And torque is measured in Newton into meter. Next comes, these are all definitions from the physics. If you get a glimpse of it and if you can understand a bit of it, it's okay. Now let's move on to the main fluid mechanics definitions. We'll go to surface tension. What is surface tension? I have written surface tension as force per unit length. Surface tension is force per unit length. That is measured in Newton per meter. What type of force it is? It is a cohesive force. Surface tension is due to cohesion. Please try to interrelate surface tension with cohesion. Any question can come in your examinations asking for surface tension is due to what property of the fluid. It is because of the cohesive forces or because of the cohesion between intermolecules. Intermolecular cohesion. There are many molecules of a fluid here. Between each other molecules, they have intermolecular forces acting between them. These intermolecular forces between this and this, between this and this, intermolecular forces cause cohesion. Cohesion means co means living together, being together. Cohesion means being together. That means attraction. Intermolecular forces. Because of this cohesion, these molecules of the fluid, they move together. They be together. Please try to understand this. Cohesion means being together. And this cohesive force, for a particular liquid, if they are together, what happens? What happens to the cohesive force? When we heat up the fluid, these intermolecular forces will reduce. That means distance between them increases. What is the force? Force is indirectly proportional to 1 by r square. Let us say, this is what is from the basics we know. As the distance increases, as r increases, what happens? Force decreases. That means whenever we heat a particular fluid, the intermolecular distances within the fluid will increase. That means R increases, and cohesive forces with temperature cohesive force decreases. That means whenever cohesive force decreases, the surface tension, cohesive force per unit length of the interface, that decreases. That means sigma, surface tension, is represented by symbol sigma. This is the surface energy per unit area of the interface, that is Newton per meter, and sigma decreases when T temperature increases. Please keep this in mind. For liquids, as the cohesive force between the intermolecules decreases. And surface tension is represented by the intermolecular forces per unit length. You please try to understand the concept. The water droplet, let us say, it will not live on its own. It is surrounded by, there is a cloud, rain is falling, there are water droplets are formed. These water droplets will not live on their own. They are surrounded by some other fluid called air. I told you gas is also a fluid. This is air. Droplets are formed. Droplets are formed due to the intermolecular forces, cohesive forces between the intermolecular forces between the molecules of same fluid. This is water. This is water. Surrounded by air. Then sigma surface tension is represented as sigma of water surrounded by air. Instead of air, that is what is called as the second liquid in our definition. This is air. Surrounded by, interface with, surrounded by. Cohesive force is due to the intermolecular forces of that particular fluid. When that particular fluid comes in contact or surrounded by a second liquid like air, then that interface connection is called as sigma water air. This value will be something. That value we can take it as sigma air water or sigma water air. It is 0.03, 0.073 Newton per meter. And sigma air mercury. For example, they are not water droplets, but they are the droplets of mercury surrounded by air. Then that value will be 0.480. These are all approximate values I have given you. Now, as a homework, you tabulate surface tension values of at least 10 fluids. They can be either air, they can be either gas, or they can be liquids. Like in liquids, water and mercury I have given approximate values. Similarly, you find out. These are all, whatever I have given, they are at laboratory T 20 degrees centigrade, and with temperature what happens for liquids, the surface tension reduces when temperature increases. This is about the surface tension. Surface tension is measured in newtons per meter. Now, this is about, I can say, 20 degrees centigrade, or we can say 90 degrees centigrade. You please take values from standard textbooks or literature. Now, when I deal with surface tension in detail, it is only regarding definitions I am talking about. I will tell you about the pressure intensity inside a droplet, inside a soap bubble. Examples for surface tension are soap bubbles, water droplets, or we can even say liquid jet. We will discuss in detail when we talk about the section on surface tension. These are only I am dealing with definitions and properties presently. I am not dealing in detail or not doing any derivations. And the sigma varies for soap bubble separately, water droplets and liquid jet. For soap bubble, the values are different. The pressure intensity, this is regarding pressure intensity. Because from sigma we can calculate the pressure intensity. Pressure is measured in Newton per meter square. That is equal to Pascal. Pressure can also be seen as a stress. Now, we will go to capillarity. Capillarity is due to both cohesion and adhesion. What is cohesion? Same liquid molecules attraction. Adhesion is between two surfaces like solid, liquid adhesion. You might have seen adhesive tapes. There will be a liquid and you will be sticking some solid to the with the adhesive like what you call adhesive liquids, Fevikwik. We will put it on the surface of the solid and another solid we will bring and we will attach to it. That is because of the adhesion between solid and liquid. And these adhesive forces between solid and liquid, what happens to them? And one more thing I have forgotten. The most important example of surface tension is very good example. This is the water surface in a tank of pool of water. Then we have put one small needle. This is needle. On top of the surface, the needle floats on the surface because of surface tension. This is one of the examples of surface tension. And in case of capillarity, you take some liquid in a tumbler and put a glass tube inside the tumbler. The shape of the meniscus will be either like this or the shape can be like this, depending upon the which type of material and what type of liquid you are using. This is called as capillary depression or capillary fall. This is called as capillary rise. This is due to this surface will have adhesion and liquid will have cohesion. This solid surface and liquid surface, adhesion, and this liquid surface whatever is there, cohesion, and due to both cohesion and adhesion there will be capillary rise and capillary fall, or we can say capillary depression. This is regarding the definition. Now, can we write a relation between this capillary rise or fall is measured in meter? Can we write a relation between capillary rise or capillary fall? That relation I will give only definition now. H is equal to this is H, this is H. H is equal to this is theta and this is theta. Let us say depression and rise and fall, the theta will be measured similar way. 2 sigma cos theta by 2 sigma cos theta by S sigma r. This is the equation. We know theta, we know r, this is the radius of the tube. We know gamma, gamma is the what you call specific weight of liquid or fluid. R is the radius, sigma is the surface tension, and H is the capillary rise or fall. And we can measure with this formula the value of H. S is the specific gravity of liquid. And there is a homework for you. From standard textbooks, find theta for glass and water. Water is the fluid, glass is the tube, this is the tube, glass tube, and water, it is the fluid. Find theta. This will be it is 0, but however you find on your own, and for at least 3 combinations. Homework is find theta for 3 combinations in capillary rise. Like instead of glass water, it can be glass mercury. I have given you hint. Glass water, it is 0. For glass mercury, theta is equal to how much? What do you find? Now, let us come to, I have only given definitions, no derivations. Please don't be in a hurry to conclude about the definitions. I have given you only what you call definitions only, and we will discuss in detail once we go into the chapters of calculations. Once we start calculating the values and doing some numericals, then we will do it. Definitely we will do. Further explanations. Now, there is one relation called as rheological relation. Which is written as tau is equal to mu into du by dy. This is Newton's law also. And here, if you see, if we draw a graph between tau and du by dy, let us take tau on the y-axis, du by dy is on the x-axis. Du by dy is nothing but hydraulic gradient. This is hydraulic gradient. This is shear stress in Newton per meter square. Any stress is Newton per meter square. Then there will be a relation. There will be graphs for different types of products. The graphs can be like this, and another can be like this, another can be like this, and another can be like this, and another can be like this, another can be like this. When the value of dynamic viscosity is equal to 0, then tau is equal to 0, then the graph will be a horizontal line. This is for mu is equal to 0, implying tau is equal to 0. This is for ideal fluid. For an ideal fluid, the viscosity is 0. It is an inviscid fluid. Inviscid means viscosity absent. That is x-axis. In a du by dy, tau du by dy relation, tau du by dy graph, in tau du by dy graph, if mu is equal to 0, it implies ideal fluid graph will be x-axis. Then elastic solid. Elastic solid means whose with velocity there will not be change in velocity with respect to change in height, change in depth. That is called as elastic solid. In case of elastic solid, the hydraulic gradient is 0. Then this graph is elastic solid. Y-axis is elastic solid, x-axis is ideal fluid, and for other graphs like thixotropic, plastic, Newtonian, non-Newtonian from this graph, I will explain you in the next class. But however, as a homework, kindly study tau du by dy graph and identify all types of fluids in this graph. Identify and draw the graph. That is your homework. Now we will go to the most important property called pressure. Pressure is equal to, we have already defined, force normal by area of cross section, that is equal to dF by dA normal, that is equal to Newton per meter square, that is equal to Pascal. And the same units of stress are units of pressure. Force by area is stress, that is equal to force by area. Force by area is either both stress and pressure also. Normal force by area. Now, these pascals are Newton per square meter. These can be expressed as, if it is unit 1, it is Newton per meter square or PA. I have explained in the first lecture itself. I am just making you to remember this. 10 to the power of minus 3 is milli Newton per meter square or milli Pascal. Then 10 cube, 1000 is kilo Newton per meter square or kilo Pascal. 10 to the power of 6 is mega Newton per meter square or mega Pascal. Please remember this. Now, as explained in the first class itself, first lecture itself, let us take one water tank filled with water up to this level, and this is atmosphere, exposed to atmosphere, and let's call this point as A, and let's call this point as B. Then pressure at A is equal to pressure atmosphere, atmospheric pressure only, there is nothing above atmosphere, this is atmospheric pressure. PA is equal to P atmosphere. Pressure at B is equal to pressure at A plus this is equal to H rho GH. We have already seen how we have got it. Pressure at B is equal to PA plus rho GH, that is equal to P atmosphere plus rho GH. Now delta P is equal to PB minus PA, that is equal to P atmosphere plus P rho GH, P atmosphere plus P liquid. P liquid is nothing but rho GH minus P atmosphere, that is equal to P liquid, that is equal to rho GH. Here in this formula, PB is the absolute pressure at point B. Absolute pressure at point B is equal to P atmosphere plus rho GH. Therefore, P gauge is equal to rho GH. This is equal to called as P gauge. Whenever we measure pressure with any instrument, that instrument gives the differential pressure. That means delta P. Delta P is PA, PB minus PA. That is equal to rho GH. That is equal to pressure gauge pressure. Because we are measuring the pressure with a gauge, that pressure is given as delta P, that is PB minus PA, that is equal to rho GH. And for calculating the pressure from a gauge, we will have a datum as P atmosphere, atmospheric pressure. The atmospheric pressure at mean sea level is 101.325 kPa, which I explained you in the first lecture, and it depends upon the latitude of the place. The general value is taken as 101.325 and it ranges as per the latitude of the location. That means P atmosphere is equal to datum basing on the place. This can also be in general notation 101.325 kPa. This is the absolute pressure. That means absolute pressure is equal to atmospheric pressure plus gauge pressure measured from the instrument. Now, it implies gauge pressure measured from the instrument is equal to P absolute minus P atmosphere. Now, let us say an instrument measured gauge pressure as 53 kPa. What will be absolute pressure? Here, absolute pressure is equal to atmospheric pressure plus gauge pressure. What is the atmospheric pressure? 101.325 kPa plus 53 kPa. The absolute pressure will be 154.325 kPa. This is the absolute pressure at that particular point. Now, let us look into few questions on the basis of the properties given in SSC JE. The question is, surrounding atmospheric pressure is taken as datum to find what? Question is, surrounding atmospheric pressure is taken as datum to find which pressure? You see, from this and from this equation, this is the datum. Like this, if you see, this is the datum. This is P atmosphere at A. It is at B. This is PA is equal to P atmosphere. This is PB. PA plus gauge pressure. Rho GH. Rho GH is the gauge pressure. PA is nothing but P atmosphere. Rho GH. That means surrounding atmosphere is taken as datum to find gauge pressure. To find rho GH, which is equal to gauge pressure. Answer is gauge pressure. Within 2 seconds, we could solve this question. Very simple question. Once you understand the concept, it will be a very, very, very simple question. If you don't understand the concept, it will not be a simple question. Now another question in the same 2024 SSC JE Civil. You just see how simple it is. The sound pressure is measured in. Whether it is sound pressure or any kind of pressure, pressure is measured in newtons per square meter. Just try to understand how simple it is. Now, in another thing, whenever you design any pump, what is the pressure you use? The pressure you use is The pressure you use is gauge pressure. These are the 2-3 questions asked. Another question asked in 2024 is units of sound pressure. You call it any pressure, it is normal force by area of cross section. That is equal to dF by dA. This is the definition of the pressure. The units of force are Newton, area is meter square. Hence the units of sound pressure is Newton per meter square. Almost 4 questions in 10 seconds we could complete by knowing the properties of the fluids, and they are all very simple, but only thing is that you should know the concept. If some question is given in a twisted manner also, we should be able to answer it. This is how the questions in SSC JE being asked, and we will be able to answer them once we are thorough in our concepts. And another question is also asked, how does the atmospheric pressure vary with respect to altitude? This is the 5th question. The atmospheric pressure decreases with altitude. This is the Earth's surface. This is the height or latitude. As height increases, P atmosphere decreases. Please remember this. Atmospheric pressure decreases. And the reasons for it I will be explaining in the next class. The reasons for it I will be explaining in the next class. It's very simple. There is a small formula is there. That formula we will apply, and we see that it's not only about the height above the Earth's surface, we can even find out the pressure variation even inside the Earth. That we will do it in the next class. Best of luck to everybody. From the properties, if you see 2024 question paper, almost 5 questions are asked. 5 marks in a competitive examination is a very big mark. Even 0.01 mark is also very big. It makes a difference in the selection and non-selection. Because 99.7% people are rejected, only 0.3% people are selected in the SSC JE. I feel the concepts of each and every topic are essentially to be known. There are questions which we have seen, nothing is complex questions here. Nothing is complex mathematical problems. They are very simple, straightforward, but little bit twisted questions. Instead of pressure, it is asked units of sound pressure. Instead of definition of a gauge pressure, they have told what is the datum used for gauge pressure. It is atmosphere. Because gauge pressure is called P absolute minus P atmosphere. Atmosphere is to be deducted. That is the datum. Just to see how simple the questions are, how easy the questions are. And if you know the, what you call, the theory behind and the concepts thoroughly, you can answer these questions very, very easily. And like also, the question is asked this regarding gauge pressure and also units of the pressure. Just see. For that only I started this lecture by defining force and then the moment or momentum in physics. P is equal to mv and then torque. These are the physics definitions, that is moment of the force. Then we have gone into surface tension definition, capillarity height definition, and then ideal fluid, elastic solids, absolute pressures, gauge pressures, and then finding the gauge pressure. What are the formula controlled by gauge pressure and atmospheric pressure, and what is the variation of surface tension with respect to temperature, and what is the variation of atmospheric pressure with respect to latitude from the surface of the earth. These are all the things we have discussed fruitfully, and we have compared our knowledge level with the SSC JE questions also. They are also found to be in tune, and we are in well placed situation. We are well placed, and our pace of learning is also good. And let's move forward with some more definitions and properties from fluid mechanics in the next lecture. Best of luck to everybody. It's Ramchandra again from Civil Mech Maths Concepts. Kindly view, review and comment on my fluid mechanics lecture number 1, and kindly view that lecture also. And if you feel my lectures are useful to you, kindly subscribe to my channel Civil Mech Maths Concepts so that you will get regular updates whenever I release new videos for Staff Selection Commission JE selection. Best of luck to everybody. Thanks a lot.